Wow, that's amazing. Hello friends, I have designed a microcontroller based DC motor speed controller. Well, I am controlling the speed of the motor by varying the supply voltage with PWM technique. So to vary the supply voltage, I am basically varying the duty cycle of the PWM signal. This PWM signal is generated by the microcontroller, okay, and the duty cycle is controlled through the potentiometer. So as the duty cycle changes, the speed of the motor changes. So in this way, the speed control of the DC motor is carried out. So here are the list of the components which I have used to design this project. The first one is the Arduino Uno, that is the microcontroller, and this one is the microcontroller. Then 12 volt DC motor, here it is, this one is the motor. Then 10 kilo ohm potentiometer, this one is the 10 kilo ohm potentiometer. Then 1N4007 diode, here it is, this one. Then P55NF06 N channel power MOSFET, and here it is, this one is the power MOSFET. Then BC548 NPN transistor, here it is, this black one. Then 10 kilo ohm resistor, here it is, this one is the 10 kilo ohm resistor, this one. Then 100 ohm resistor, here it is, this one. And finally 200 ohm resistor, here it is, this guy. Okay, so let's move forward and see the schematic representation of the project. And here it is, this is the schematic representation. See, let me explain. This is the microcontroller, and the PWM signal is generated from the pin 9 of the microcontroller. And in the pin 9, I have connected this. I have connected basically to the base of the NPN transistor through a current limiting resistor, that is 220 ohm. This current limiting resistor I have provided to limit the current, base current rather. Okay, and the emitter of this transistor is connected to the gate of the N-channel power MOSFET with a current limiting resistor of 100 ohms. Okay, so what this transistor, this NPN transistor, is basically driving the gate of this power MOSFET. Okay, and this the supply voltage to the transistor is 12 volt, and the supply voltage to the motor, which is connected in series with the MOSFET, is also 12 volt. Okay, so and this 10 kilo ohm resistor is basically the pull down resistor which is connected to the gate of the N channel power MOSFET. And see here, the 5 volt supply from the microcontroller is provided to one side of the potentiometer, and the other side is connected to the ground. Okay, and the signal pin of the potentiometer is connected to the analog pin 1 of the microcontroller, and the ground of the microcontroller is connected to the negative supply of the power supply, and the source also negative supply. Okay, and the V in pin is connected to the 5 volt supply which is provided to the microcontroller. So let's see how it works. So basically what I am doing, I am just changing the potentiometer, means I'm just rotating the pot, this one. What I'm doing, I'm basically rotating this, I'm basically rotating. So what it is doing, what is this? It is basically a variable resistor. Okay, it is variable resistor. So it is basically what it is doing, it is basically changing the resistance, and what it is doing, ultimately changing the voltage. Okay, it is basically changing the voltage, and that voltage is basically the analog signal. Okay, that is the analog signal, and that analog signal is fed to the analog pin 1 of the microcontroller, and inside the microcontroller there is a analog to digital converter that is of 10-bit. Okay, so what it is doing, it is basically converting this analog signal into digital signal, and that is processed by this microcontroller, and from there, according to the code which is programmed here, that we will see it later on. Yeah, this from the pin 9, the PWM signal is generated. Okay, so this is the simple working of this small project. See, as I'm changing the knob of the potentiometer, the signal is read by the microcontroller from the analog pin 1, and the program is executed inside the controller, and the PWM signal is generated, the pulse width modulated signal, like this. The pulse width modulated signals with controllable duty cycle is generated from this pin 9. Okay, so as the duty cycle changes, so its average voltage changes, and this variable voltage, this small variable voltage is passed to the base of the transistor, and accordingly, as the base voltage base voltage varies, this collector to emitter voltage also varies. Okay, so what it does basically, this variable voltage also gets fed to the gate of the MOSFET, as here, as the gate voltage varies, so accordingly this drain to source voltage varies. So with the drain, with this MOSFET, this motor is connected to this in series with this MOSFET. So as the drain to source voltage gets varied, across this motor, the voltage also gets varied. So we know that the speed is directly proportional to the supply voltage. So when the supply voltage decreases, the speed also decreases, or when the supply voltage increases, the speed also increases. As simple as that. So this fundamental concept is applied here to control the speed of the motor, and it is very much efficient technique. This PWM technique is very much efficient to control the speed of the motor. Okay, I hope everyone has understood this. So let's move forward and see the code. So here it is. This is the code of the project. So what I have done, basically I have declared a variable here. I have declared a variable globally. Okay, that is the integer type. I will use it later on. And in the setup function, I have declared pin 9 as output. Then in loop function, what I am doing, I am storing the what I'm doing, I am reading the analog signals from potentiometer. I am reading the analog signals from the potentiometer, and I am storing in the knob value, variable knob value. Also, I am and then I am mapping the knob value from 0 to 1023 with 0 to 255. So as the inputs the analog to digital converter is of 10-bit, so the range is, so I have provided the range, that is 0 to 1023. Okay, and the output, the converter, the analog, the digital to analog converter of this microcontroller is of 8-bit. So the value is from 0 to 255. So I'm basically mapping these values, and the mapped value is I'm storing this to the knob value. Okay, and finally what I am doing, I am just outputting that mapped value to pin 9. That's it. So that's it. It is very simple. The code is also very simple. The schematic, the circuitry is also very simple. This one and this one, very easy. Everyone will able to make this project, small project. It is very easy. So that's it. I hope everyone will like this video, obviously. I hope so. If you like this video, then don't forget to like, share and subscribe. Stay tuned with me for this kind of tech videos. Thank you. Have a nice day.